Audio is okay?
No, sir,
Hello?
it's break.
Hello? Hello, could you please type it in the chat box? If not, I'm sharing my screen. Hello?
Yes, sir.
Could you please type it in the chat box?
Your voice is not clear, sir.
Voice is breaking. Is it? I think I have a little bit internet problem with my native place. Is it not happening? Is it with voice? Now I will remove my earphone. Could you please tell me my voice is okay or not right now? Hello?
Yes, sir. It is clear, sir. Now.
Now I have. Now, hello? Yes, okay, thank you. Let me start the class. Okay, now I have shared a screen. Could you please look at it? We will continue yesterday's unification algorithm and we will go to forward chaining. Okay, is the screen is okay? I need, could you please anyone could you please tell it whether my voice is okay?
Yes, sir.
Hello?
Yes, sir.
Yeah, give me a minute. Yes, sir. Okay, shall I go? Is it visible? Could you please someone
Yes,
echo from you, from
yes,
your
sir.
side? Hello? Hello? Is it visible?
Yes, sir.
Hello? The screen is okay for everyone?
Yes, sir, it's visible.
Okay. Yes. Let me increase the voice. Now, yesterday we are discussing about unification algorithm. In this, we are having two things. Let me discuss with a line. Sometimes we are replacing x with a variable. Okay. Sometimes you are replacing x with a variable. Okay. Sometimes you are replacing variable with a value. Yes or not? I need answers from you. In one of the application, we replaced x with John. Okay. In one of the example, we replaced a variable back with a value. Yes or no? Now, from this topic, I will try to start my algorithm. Okay. Now, I need kindly respond yourself. Hello.
Yes, sir.
Trived, could you please, CR, could you please inform me whether my voice is okay? Shall I go?
Yes,
The
Yes.
time is wasting. Please inform me.
yes, sir. It is okay. You can carry on.
We are, yes, please check the speakers. We are speaking, sir. Wait a minute. I don't know something. Oh, okay. You can respond through chat box. Okay, I'll open the chat box. Okay, now, and your voice is okay, sir, and we can carry on. Yes, thank you. I will carry on the topic, and if you find any problem, you please type it in the chat box. Okay, then we will go, please. Yeah, I think it is okay. Then let me go to just 5 minutes about yesterday's problem. Then I will incorporate them in the algorithm. Okay. Yesterday we discussed about 5 cases. Now I'll go a little bit faster, okay? Because anyway we have discussed them in the last class. Here we replaced the x with a variable, okay? That means whenever we have an x, there we are replacing Jane. Then now this FOL, known John of X, and I can replace with John of Jane. Okay, now I can call this as alpha and this as beta. Okay, this we call as theta. Okay, if alpha is equal to beta, okay, if alpha comma beta is equal to theta, then we will call it as unify the process. Unify is a function, okay, which will replace this FOL with this FOL. Okay, now this is the first one we have seen yesterday. Then here, if you look at this example, second one, wherever X is there, we are replacing with Richard. Okay, and wherever Y is there, we are replacing with John. Okay, then I can replace this alpha with this beta. Okay, when this theta is true. Okay, now yesterday you said that it is okay. Then in third case, you said that it is wrong. Okay, because I cannot replace two variables with two different values. It is wrong. So it is not a unification process. Okay, so if we want to go to unification process, what we have to do is you should go for standardization apart concept. Okay, standardize apart principle. According to this principle, what I can do is we have to rename this X with another any variable. It can be Y or it can be Z. Now if I tell you X as John and Y as Richard, then it is okay. Now this equation alpha and this axiom beta will be equal. Now yesterday I have discussed it. Okay, two sentences happens to the same variable, then we are using standardization apart. Okay, what we have done, we are renaming the variables one sentence to avoid the name clashes. We have also used this example while doing resolution problem. Okay, resolution in step 6. Okay, then I can replace X with John and Y with Richard. Then unify is okay for this statement. In previous example, here unify is wrong. Okay, now in this case, now here if you take this example, wherever X is there, we are replacing with cat. Wherever Y is there, we are replacing with dog. But here we are calling the function. Recursively, we are calling the function. Function will call here G of cat and dog, and here G of cat and dog. These two are matching. Then if once these two are matching, then it should go for the second one. This is called as rest sentence. This is called as first sentence. This is called second arguments. Okay, are called as rest in our as per our algorithm. We are called now f of g of x dog of x, and here also I have f of x, g of x, and dog of x. Both are equal. I will call you same principles I am going to use in my algorithm. Okay, now look at here. Here now my X and Y are two sentences, and theta is my substitution constant. Okay, here we are discussing about these points. If variable is X, okay, we have to return the unify of the variable. We should call this function. Okay, now xy theta is exact same as yx theta. It is as per the principle of unification principle. Where xy with theta is unified, it is satisfied. It will also satisfy with y comma x with theta. Okay, so do you have any problem with the first two statements? I think as per my knowledge, wherever we have replaced xy and vice versa is also true. So wherever the variable of x will replace the variable, you can also replace y with x. Okay, third one is if you are having a compound sentence, that means one sentence next one sentence or compound means compound of several sentences. Single sentence. Sentence means within we have any number of sentences. Okay, at that what are the argument operation. Okay. And in the last case, what we discussed, if you have list, okay, if you have list, and it will X is one list, Y is another list. We will take the arguments. If there are matches, then we will go for this. Rest will be in the loop. Okay. And one by one row, one row at a time, it is checked. Yes. So we call unit with when it is substitution function. And if it is okay, then we will call this recursive function. Observe carefully. Unify of x dot first and y dot first. Okay. Now we will apply this concept for x dot rest and y dot rest. The same unification principle we apply for x dot. Now the second will become okay. The remaining value becomes continue this process. We will continue the process. Okay. Now I will wait for 1 minute. Now if you have any problem, I can box. Sorry for the network problem. Hello, now is it okay? Hello? Hello?
Yes, sir, your voice is audible.
Yes, sir.
I think maybe internet. Could you please tell me where where we have stopped the discussion when we lost the connection? Now from the PPT. Can anyone suggest me? Hello? Okay, please for everyone. Shall we move?
Sir, your voice is breaking, sir.
Aman, నేను మీకు recently I told that because of unavailable situation, I went to my native place because there is a problem in internet. I'm using my internet regularly. It is not happening. Hello.
Sir, your voice is breaking.
It is because of internet problem. Okay. For this day. Could you please adjust the internet connection for this day? Hello.
Yes, sir.
Is it okay? Is it audible?
Yes, sir.
Yes, sir.
Yes, please. Yeah, as far as today is concerned, please kindly cooperate with me. Tomorrow afternoon, I'm coming to Hyderabad again. Okay, please. Anyway, we are discussing about unification. Please let me close this algorithm. I think all these steps are okay. Hello? With yesterday's discussion. Hello?
Yes, sir.
Now, yeah. Now there are four cases. If xy is unify is true, then yx is also true. This is the unification principle. Okay. If x is alpha and y is beta, by using this substitution theta, if these two sentences are unifying, and the same thing we can also infer that yx also unifies. Okay, so these two are same. Okay, then if it is a compound statements, we are going to replace with operators with arguments. Then if it is a list, we are going to first check with these arguments. This is the algorithm. Yesterday we have closed it. Now in these functions we are calling another function. Could you please look at this? Is it a unify variable algorithm? Hello. Now actually speaking, unify is the outer function. Okay, there is an inner function called as unify underscore variable. Hello. Now in this unify underscore variable, now simply kindly follow this principle. Wherever x is there, we are replacing with. Could you please anyone echo with what we are replacing? Hello. Could you play? Can anyone tell me with what we are replacing? Somebody could you please echo with me? Kindly. Now wherever x is there, we are replacing with a variable. Yes or no? Hello.
Yes, sir.
That's what
Yes,
I'm asking. ఈ రోజు నాకు కోఆపరేట్ చేయండి అని అడుగుతున్నాను కదా. Since 14 hours
సార్
I'm
ఇందాక
trying.
మేము మాట్లాడినప్పుడు మీకు వినిపించలేదు సార్, అందుకని చాట్ బాక్స్ లో చెప్తామని ఆగుతున్నాం.
ఓకే ఓకే, ఒకసారి ఇప్పుడు వినిపిస్తాను కదా, మాట్లాడొచ్చు కదమ్మా.
మీకు వినిపించట్లేదేమో అని ఆగిపోయాం సార్.
అయ్యయ్యా, నాకు వినిపిస్తుందమ్మా, నాకు ఇప్పుడు వినిపిస్తాను, నాకు చాట్ అంతా బాగానే ఉంది. ఓకే, ప్లీజ్ కైండ్లీ కోఆపరేట్ విత్ మీ as far as today is out of station. Okay, please. Now with this now let me, now is it okay? Can anyone speak a word? Now we have seen all these if else cases regarding unification functions. Okay, now if you want to write these rules, you should go back to these functions. Here what we are replacing, if x is a variable, what we are replacing, please can anyone tell me? Hello. Hello?
Richard, sir.
Yes. No, no, not Richard. Don't tell me Richard. It is called as, please, if X is a variable, don't tell me Richard. In this example, it may be Richard. But if you aren't write algorithm, you should write in a generic way. Okay. If X is a variable, we are replacing with now can I call Richard, John or variables? You can replace with any name.
Yes.
Hello? No, that's what I am asking. Whatever we are discussing in the example, we are going to transform with algorithm. Are you getting me? Now, what you will write it is, if my unification sentence is variable is X, I am replacing with variable. Will you agree now? Yes or no?
Yes.
Now, one more question. If I have existential quantifier, please. If I have existential quantifier there, I have an X. With what I am going to replace?
Scholen constant.
Scholen constant. Can I call them as constant? Are you getting me? Now, if it is a universal instantiation, we are going to replace a variable X with we are replacing a variable with a specific name. Okay. If it is there exists X, we are replacing with a constant. The same thing we are going to replace here. That's it. Now observe carefully. Now please. Here what we have done. If variable value belongs to theta, okay. If value, if we are replacing with a variable, it can be Richard, John. Will you agree? That what I am doing, what I am replacing with, I am replacing X with a value, yes or no? Hello? If this condition is happening like this, what I am replacing? Please, I am asking n number of times. If I have the condition like this, okay, a name with X, what I am replacing in the unification? Is the value is looking here na? X with some value. It can be a Richard, it can be a John, it can be a Laika, it can be Jim. Yes or no? Could you please answer me?
Yes, sir.
That's what I'm asking. Now, if maybe in one of the resolution example, we have done reverse also. Okay. Now, for example, if I have a value, if I want to get back my Scholen constant, can I replace a value with an X? For getting this example, you can look at the previous problem statement. Did we replace a value with a variable in 6th step? Hello? Could you please check the step number 6 or step number 7 in the previous problem? We have done sometimes if I have, this is reverse process. Okay, this everyone know. If I have a variable X, I am going to replace with a value. It can be a John, it can be a Richard, it can be a brother of John, it can be a son of John, and so on. Whereas if I have the equation like this, are you getting that? Means we are replacing a value with a variable. The same thing which we have done in our previous example. Shall I go to that example and show you? Hello?
Yes, sir.
Yes, please. Give me a minute. I will share that PPT. How we have written that rule. Okay. Now let me show you that screen. Just give me a minute. Look at this example. I already told this example previously. In step 6 or step 7, I am saying that all these are unification rules or not? Yes or no? Here, name is my Scholen constant. Whenever I have there exists symbol, in the previous example, we have replaced here. We have replaced name with here. Now, whenever there exists symbol, please observe carefully. Whenever there exists symbol, what we have done? We are replacing the graduation Z with name 1. Now, in this 7th step, what we have done in unification process, wherever I have W, I am replacing back with name. Yes or no? I am replacing here. I will call it as a value with a variable. Yes or no? Am I doing the reverse process? The step 1 you are doing for universal process. For example, if you look at this, go to PPT. If it is a classroom, it would be better. Please, here, if I have there exists symbol, now X is going to replace with value. If there is Skolem constant, what we have done? Are we replacing values with the variables? Their name, you can write any name. Are you getting me? This is nothing but hello. This is exactly nothing but existential instantiation. This is universal instantiation. Now, else if there are nothing, then you have to check the occurrences, all the occurrences, and you have to replace it. Okay. If these two cases are not applicable for unification of the variables, then what you have to do is you have to check the entire knowledge base. Okay. Each and every occurrence you have to check, and you have to replace that X with a variable. Okay. And this case we are calling it as failure. Okay. Hello.
Yes.
This case we are replacing with now this is called as the unification algorithm. Whenever in the examination, if they ask about unification algorithm, you have to write these 4 steps, please. You have to write this principle, please. You should write this, sorry, not this principle. Yes, you should write this principle, okay? Unify of alpha comma beta is equal to theta. If alpha comma alpha theta equal to beta theta, then you should write this example. Everyone who studied your textbook, they knows about king of X and greedy of X, able of X. Please take the same example in the examination, okay? Because the people, those who are coming for evaluation, they know about this textbook. Clear? Now, with this, I will start today's topic. Yeah, today's topic is forward chaining. It is another kind of inference mechanism. Is it visible? Before going to forward, before going to forward chaining, I need some modus ponens principle to understand about this principle. Okay, this is the last class topic. Okay, maybe 5 days back topic. Here, modus ponens means we have sentences. If they are in the form of P implies Q. Okay. If I have another sentence P, okay. Now, if I have AND operation between them, always we are going to return Q. Is it okay? Shall I call it as modus ponens? Yes or no? This is the solution. How we got P implies Q and P. How we got Q. This we have already discussed it. Now this we have used in preposition logic. In first order logic, we are naming it as generalized modus ponens. So they are calling them as GMP. Okay. In the previous class, I did not discuss about GMP because GMP will come here itself. Now, shall I go to GMP? Everyone knows about modus ponens?
Yes.
Yes, sir.
Now, can anyone tell me why it is called as a generalized modus ponens? Amma? Please give me a minute. Hello, shall we go? Sorry. Hello? Hello?
Yes.
Yes. Now, shall I call, can anyone tell me why it is called as generalized modus ponens in FOL? Because in first order logic, always we will deal with generalized conditions. Yes or no? In preposition logic, we call it as modus ponens. Okay, P implies Q and P, we call it as modus ponens. Whereas in first order logic, the same mode exponents can be called as generalized mode exponents. Now shall I go? Now, yeah, please look at here carefully. For every substitution of P, okay, for every substitution of P such that for all I, the principle is unifies P implies P prime. Here it is called as P prime, also called as negation of P. Okay, hello. For every substitution theta such that for all theta unifies wherever there is a P, I can replace with the P prime. Now if you apply this formula, now I have P1 to Pn prime, then P1 to Pn, I can use Pi or I can use P prime. Are you getting me? I can use P or I can also use P prime. Implies Q. Exactly same principle we are using. Instead of using P, now in unification principle, wherever I can use P, I can also use negation of P. Because of this principle, now shall I continue? Hello? Please observe this point. Because of this principle, wherever I am replacing P, I can, in unifies, I can replace with negation. I can substitute P with P prime. P prime is nothing but negation of P. So, can I change my mode exponents principle as P prime and P implies Q? Please kindly answer me.
Can you repeat GMP, sir?
Look at this formula of GMP rule for every substitution of T such that for all, you'll just look at here. I'm using for all. Okay. So what I'm doing is now unification principle applies wherever Pi is there, I can replace with, or I can, as per this unification, I can replace with P prime, also called as negation of P. Yes or no? Because of this principle. Now, can I replace my equation? Earlier we have written it as P. Now, can I write it as negation of P? Because of this unification principle. Can I write? My simple example, observe carefully. If P1 is king of X. Now, can I write P1 dash as king of John? Am I replacing X with John? Now, can I call it as P1 prime? Sorry, it is not negation. Can I call it as P1 prime? Wherever P is there, can I replace with king of John with the variables according to this unification principle? According to the unification principle, wherever X is there, I am replacing with a variable. Yes or no? Can I write king of X with king of John? Hello? Please kindly respond, Amma.
Sir, we can replace, sir.
That's what I'm asking. But if you don't say anything, how can I move? Now, can I replace this greedy of X with greedy of Y? One variable I am replacing with another variable. Now, able of X, can I replace? Now, what is the meaning of able of X means greedy of X, and there is a principle you have seen it now in the previous class. King of X and could you please continue?
Greedy of X.
Yes, then can I replace it with that able of X with X John and Y John? In the previous example, we have already completed this. Yes or no?
Yes, sir.
Now can I call if it is q, and if it is theta? Now q theta means, now wherever x is there, can I replace John? Now can I call it as evil of John? Here what we are doing is we are using a principle of definite calculus. Let me discuss one line about what is definite calculus in GMP. Okay, GMP assumes that entire knowledge base consisting of exactly one positive literal. Okay, you should have only one positive literal. Okay, by default all variables are assumed universally quantified. Whatever the variables we are using, all these variables are universally quantified. Universally quantified means you can use x with John, you can use x with Richard, you can use x with father of John. Okay, yes, otherwise you please observe simple carefully. Wherever I can use p implies q and p, here I am getting q, this you know. As well as generalized principle, what we can do is wherever p is there, please, wherever p is there, I can replace with p prime. P prime is nothing but if I have x, I will replace with John. If I have x, I can replace with y. Yes or no? If this principle is okay, now can I call it as, can I call if it as p implies q? Yes or no? This is exactly what is mode exponents. P implies q and p, you will get q. Yes or no? Simply we are unifying. Wherever p1 is there, I am replacing that x with a variable that I am calling it as a new variable p1 prime. Now are you getting me? Is it exactly same as p implies q? Yes or no? Hello? If I am replacing the x with John, my q naught will be able with John. Yes or no? What would be my outcome? My outcome will be q itself. Whatever I will take q naught, that will be the result. Evil of John is correct as per of generalized mode exponents. Could you please respond to me? Please. Yeah, please once again. I did not get you. Can I replace p implies q? Wherever p is there, can I replace with p1 prime? Where p1 prime is x, because of unification process. Because of unification process, I can replace x with John, x with Richard. Because of unification principle, I can replace one variable with another variable. Now, can I write my equation to be suited for all the generalized rules for p implies q? Can I replace with as p prime implies q? Nothing is there in this. We have already solved in the previous example about everything. We have solved it. In the previous example, I already told you what is this mode exponents. I have already told you several times. If p implies q is there and p it will give you q. If you know this principle, wherever I can have p, can I replace with p prime? Hello?
Yes, sir.
Can I call it as generalized modus principle? Because I have, wherever I have x, I can replace not only with John, I can replace with Richard, I can replace with my name, I can replace with your name. So can I call it as unification process in GMP? That is what I am asking. Wherever we have p, can I replace with p prime? Because of quantification process of universal rule and there exists rule, I can replace x with any variable, any name. So I can replace p1 with p prime. Yes or no? Here I am saying that king of x, I can write it as king of John. Wherever x is there, I am replacing with John. Now, can I write my formula as p implies q or p prime implies q?
Yes, sir.
That is what I am asking since 5 minutes. Since 5 minutes, I am asking the same question. I am going to use this principle in forward chaining. It is important for examination purpose. Okay. Actually, in your textbook, it is a complex algorithm is there, but I have taken very simple algorithm. Please, one line, one short definition about forward chaining. It is one kind of inference mechanism. Okay. Always we will start with knowledge base and we will end with a goal. Please observe carefully. We will start with a knowledge base and we will end with a goal. Okay. Somewhere we will start and wherever we find goal, we will stop it. Like we have done it in your Romanian example in the graph. Yes or no? Forward chaining, what it will do is always it will start with a knowledge base, and in each and every step it is going to add a new facts or new statements using the formula of GMP, using unification. Okay, unify plus GMP. That's that. Further purpose only I discussed about the GMP principle. Clear? Now I will try to repeat all these steps until we reach the goal. Okay, shall we first do some example, then come back to this algorithm?
Yes.
Yes, sir.
Now, please.
Yes.
A simple thing. First, we'll take a knowledge base. Knowledge base is nothing but some set of sentences. Okay. We will also call it as FOL. Is it okay till now? Now my FOL consisting of several statements. Anyway, I'll start with one statement. Okay. I will start with any statements. It can be 1, 2, 3, 4. I will start with any statement, but I will conclude. Ultimately, I will reach a goal. This is the exact rule of forward chaining. Okay. Now, this is the algorithm. Kindly follow the same algorithm. Start with knowledge base, add any facts we generated, okay, with GMP. Now, in order to generate these sentences, here we are going to use GMP, stands for generalized modus ponens. It is the combination of unify plus GMP. Now, repeat until you reach the goal. Now, let me discuss with the next. Now, everybody, please take this sentence on your notebook. This is exactly from your textbook. Kindly observe the knowledge base. If you understand this knowledge base, we can write FOL statements. Very easily we can write it. The law says that it is a crime for an American to sell weapons to his hostile nations. Like America, hostile nation is Cuba, I think. Okay, or Iran, Iraq. Okay. Now, please, the country no. An enemy of America. Okay. Now, no is an American. Please, from this statement. Now, what this law is saying that it is a crime if we sell weapons to hostile nations. If you take America, the hostile nations are America or Cuba, maybe Iran or Iraq, whatever it may be. Now, there is one person called as no. He is an American. Okay. He is an enemy of America. Okay. He has some missiles. Now, no has some missiles, and all of its missiles he is selling to Colonel West. Okay, are you getting me? Now, we should prove that Colonel West is a criminal. Hello? Hello? Yeah, is it okay? The statement is okay for everyone. Please take it. We'll try to solve this problem. And this is the proof. Colonel of West is a criminal. Okay. A country no. Now, for example, sorry, country no is hostile nation for America, and it has missiles, and all these missiles sold to its Colonel West. Colonel West is an American. Okay. Now we should prove that Colonel West is a criminal. Sorry, I am misunderstanding it. Okay. I should prove that Colonel West is a criminal as per this law. Okay. Shall we start? Hello. This is a knowledge base, and this is the query. In your textbook, he called it as the statement. He called it as knowledge base, and to be proved, we should call it as query. Shall I move? Please.
Yes.
Now, we will break the knowledge base into small. Then we are going to create FOLs. Observe carefully. Now, the first statement. What is the first statement? It is crime. You can, okay. It is crime for an American to sell weapons to hostile nations. Okay. Now, If you convert this sentence into FOL, okay, you have three things. Okay, three facts you have. Somebody American, okay, he has weapons, and what he is doing, he is selling, and he can be called as the as per law. Before this, there is a law. Okay, as per law, if anyone is doing this, he is a criminal. Is it okay? Now write it. American of X. Okay, he is an American, and he has a weapon Y. Okay, he has weapon Y. We don't know in this statement. We did not get what is that Y. Okay, he has a weapon Y. Weapon is a missile. In the missile statement, he has given in this sentence, but we are in the first statement, so we don't know what is this missile. Okay, so we call it as Y. Is it okay? Then he sells. What he is selling? American. He is selling a weapon Y to Z is a hostile nation. Okay, so we call it as hostile of Z. And what to be proved? Something to be proved as criminal. Okay, we will call them as criminal of X. Okay, is it okay? Please take it. We'll continue the FOL. Hello? Yeah, please take it. Completed? Is it completed?
Yes, sir.
Now, look at the next statement. No, some sentences has missiles. Okay, no is as per the statement. No is an enemy of America. Okay, he has missiles. Okay, sorry, earlier we have misunderstanding statement. Okay, no is an enemy of America, and he has some missiles. He is selling missiles to his Colonel West. So we should write this statement. No has some missiles. Okay, some here we have some missiles. So we should write it as there exist of X owns. Okay, there exist of X known X no some X and missiles. And hello.
Yes, sir.
Yeah, please don't take this. This I will discuss in 2 minutes. First, after taking this, you please tell me. There exists X own of no X and missiles of X. He has missiles, so you should use and symbol. Okay, we cannot use implication. This I will discuss in 2 minutes. If it is completed, you please tell me. Completed? Completed?
Yes, sir.
Yeah, this statement consisting of two jobs. Please observe carefully. Now I have to eliminate there exists symbol. If I want to eliminate there exists symbol, now I have to go for column constant. Now wherever X is there, we are replacing with M1. Is it, shall I call it as column? Yes or no? Please, yes or no? I'm using two principles. The first principle is
Yes,
yeah, I am EI. First principle I am applying is EI. Is called as existential elimination. Okay, so wherever X is there, I am replacing with any name. Here, now I can eliminate this. Second principle, what I am doing is and elimination. Now my statement should not consisting of and symbols. So I will take owns no of M1 is one sentence or one FOL, and here also wherever X is there, we are replacing with M1. Now missile of M1 and take it as another sentence. Yes or no? I'm breaking the sentences later because I have to write the forward chaining principles. Now, wherever end symbols are there, now can I write this sentence in this way? Can I write this statement in this way?
Yes, sir.
Now, it's simple, na? We have removed universal instantiation. Wherever X is there, we replace it with a column constant. where Coulomb constant is m1. That's it. Please take it. We'll go to third sentence. Shall I move? Shall I move?
Yes, sir.
Yeah. What is the next sentence after this two? Is na? All of its missiles. Okay, please. All of its missiles. Here they're saying all of its missiles were sold to it by Colonel West. So all of X missiles of X. And who is owning? Who is owning the missiles? Who is owning the missiles? Egypt? No, no. Yes or no? No. So
Yes, sir.
owns of no FX. Then implication here. Implication is coming. Sells. He is selling to whom? West. Are you getting me? Please. All of its missiles were sold to it by Colonel West. Now with this my sentences are completed. Now if you have implications, what to do? Shall we go?
Yes, sir.
Now we have a small sentence. Missiles are weapons. Okay, can we infer in this way? Missiles are weapons. Yes or no? Sometimes he is using missiles. Sometimes he is using weapons. Here, yes or no? Here he is using weapon, and somewhere he is saying that he has some missiles. What is the meaning of it? Can we infer weapons with missiles? Can I write weapons of X as missiles of X in the unification process? Hello? Kindly cooperate with me. Here in this sentence, he said that it is sell weapons, and in this sentence he is not using weapons. He is saying that he has missiles. Can I infer missiles with weapons? That is,
Yes, sir.
please respond to me.
Me.
Can we write this statement? Please neg it.
Yes, sir, we can.
Yeah, shall we go? Completed? Shall I move?
Yes, sir. Continue.
Okay, please observe carefully. An enemy of America. Sometimes in sentence he referred as enemy of America. Somewhere he referred as hostile. Yes or no? You check the sentence once.
Yes,
Now,
sir. Refer.
can we refer enemy of X? Enemy of X, okay? Enemy of X, America. Now, can I have X as America? Enemy of X. He is a, can we call him as a no? Hello? Can I infer enemy of America or hostile of X? Both are same. Hostile nations. He already specified, because in the unification process you should understand this sentence carefully. Okay. Sometimes he said that as hostile nations. These are enemies. Sometimes he calling this some country enemy, called as no-nos. That is what we should prove. So can I call enemy X of America as hostile of X. Hello,
Yes, sir.
please. Shall I move? This is exactly simple inference recursion like resolution. Maybe first example, it may give you a little bit difficulty. Okay, shall we move? Maybe you may get the same kind of example. It is exactly from the textbook. Now, I will try to take reference examples from your examples. Okay, we will try to solve 1 or 2 examples in forward and backward chaining. This is exactly from your textbook. Okay, but we should not prefer textbook examples in the examinations. Sometimes they may go to exercises. They may pick any one problem from the exercise. So we will do 1 or 2 examples in the exercises, okay, in the coming days. Shall I go? Now, West means who is West who? Now, can I call West means American?
Yes, sir.
Yes, please take this. Now, I got the all inferences. Now, slowly I will go to forward chaining. Now we have 4 minutes left. Please make it fast. Shall I move? Shall I move?
Yes, sir.
Please. The country no, an enemy of America. Now, can I write in this sentence? Now, wherever I have enemy, now no and America are enemies. Can I write it? That means what we are doing is a big sentence we are writing in a smaller one. We are taking each and every sub-sentences. Okay, and we are inferring each and every sub-sentence. Okay, once you complete it, and you will get everything. Okay. Now, I can also write enemy means no and America are enemies. Please. That's what I have divided that bunch into small particles. Shall I close? Shall I move? Please. Where we have to start? Okay. Please observe carefully. Now, forward chaining means what is the algorithm we have proposed it? Start with the knowledge base. Okay. Now, all these are my knowledge bases. All these are my America, weapons, cells, hostile nations. All these FOLs are my knowledge bases. Okay. Now can I America, West, missile of M1, owns of no M1, enemy no American. Can I take them as knowledge bases? Now from this, now I'm going to infer one sentence with another sentence. Okay. At the end, what I have to prove is Colonel West is criminal. I should prove it. Okay. Now we have converted this knowledge base this sentence into knowledge base using FOL, and forward chaining, we are going to take one sentence at a time. You can take any sentences, and at the end you should prove it as criminal. First, let me show you the proof. Yeah. Observe carefully where we have started. We have started at knowledge base. Take any of some sentences. Now, what is the second statement of algorithm? Add any fact, please. Start with a basic knowledge base and add any facts that can generate generalized modus principle. Okay. Now you are adding some principles here. Earlier we don't have any principles. Okay. Earlier we observed these 4 sentences: enemy, America, missile X, weapon, and so on. These are, we observed them. Okay. Now by combining one or more sentences, I may get, please give me a minute, please. Now here, this is the first one. Now missiles, we know that they are M1 and owns by Nano. Okay, who is holding these missiles? I think we know that no. Okay, that's now from this statement, what statements I can, now this I will combine it. Now missiles are owned by no. Okay, and he is selling to west. Observe carefully. Now, if I combine these two sentences, please observe. If I combine these two sentences, we are getting cells. Now, you should put all your sentences at one side. And now, if I know missiles and wounds, can I replace with cells west? No, no. Hello? Hello?
Yes, sir.
That's what I'm asking. Okay. Now, can I infer cells of west? Here, X means we know that missiles. So, now with this, can I infer in this way, yes or no? Now, from this missile M1, I know that missile is a weapon from this statement. Can I call it as wherever missile X is there, can I replace it with weapon of X? Yes or no? Where I know that X is M1. Hello? This I will call it as 2. Third statement is, we already inferred that enemy of No and America. Okay. Now, we already informed that enemy of No America can be referred as hostile nation. Can I infer enemy of America? Here, X means No. Who? Can I call it as hostile of X? Yes or no? This I will call it as step 3. With this, I will wait for a minute. If you have any questions, you please ask me. Till now, is it okay?
Yes,
Hello?
sir.
Please. Next, please. Then, we know that weapons of M1, cells and hostile nations. Now, who is that? We already know that weapons are missiles M1 and selling. Who is selling? No. Okay. No is selling missiles to West. Now, if we combine these 3 statements, please, if I combine these 3 statements from equation 1, please go to equation 1. Now, can I call America of X, weapon of X, cell of X, hostile of X? Can I call them as criminal of X? Hello? Can I show it as criminal of X? Hello? Now, if I combine all these set of statements, now can I refer all these sentences as criminal of X? Now, so what I'm doing, same thing. Now, I combine all these statements and I call it as who is criminal. Ultimately, this statement is referring it as American West as criminal. We have already shown here American West. Okay, here already we have shown the American West. And here we have already shown American West. So finally, can we prove that in that example, already they have given West is Colonel West, please. Are you getting me? Colonel West. Now, shall I call he as a criminal? Shall I show him as a criminal? From this West principle, please. From this West principle, can I call American as criminal? Hello? Hello? We know that Colonel American is West. So we proved that he is selling missiles to West. Now here, both are coming into one conclusion. Now I can prove that Colonel West is a criminal. This itself is called as forward chaining. Maybe for first example, you may get some sort of problems. Maybe in the next coming sessions, we are going to write another 2 to 3 examples. Okay, then you will get total everything. Okay, tomorrow we'll continue the backward chaining and we will close the unit 2 and we will go to exercise problem, solution of the exercise problems in the coming days. Clear? I'll put this video kindly. Hello?
Yes, sir.
Why somebody 55 students are there earlier?
Sir, class is done by 11:10, sir.
Sorry,
They
sorry,
have to
sorry.
join the
sorry.
other class.
Sorry. I have not seen. Sorry. Okay, thank you. Thank you very much.